due to the unsaturation in the benzene ring, we can expect electrophilic substitution reaction, whereas nucleophile is an electron-rich species. Electrophile means electron-deficient species. The mixture of concentrated H2SO4 with HNO3 is known as nitrating mixture. Halogen in the sense, the process of addition of halogen group to the benzene ring is known as halogenation. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called Hydrocarbons. Under that, we have discussed about the aromacity and aromatic characters in the benzene ring, and also we have discussed about the Huckel rule, and also we have discussed about the condition for the aromacity, and we also discussed about the method of preparations of benzene, and we have discussed about the physical properties of benzene. Today, let us move on to the last topic of this unit about the chemical properties of benzene and directive influence of functional group on monosubstituted benzene and carcinogenicity or toxicity. We are going to understand in this session. Okay. Let's see what are the chemical properties which are exhibited by the benzene. We are already know that benzene having a 6 carbon atom with the 6 hydrogen atom, and it shows a lot of unsaturation because of the presence of alternative 3 double bonds with a single bond. Is it right? Yes. So benzene does not give a reaction characteristics of the unsaturated hydrocarbons. On another hand, it is quite stable and gives substitution reaction because of the high electron density on the ring and electron deficient group. It can attack to give rise to the electrophilic substitution reaction. So the typical reactions which is exhibited by the benzene are, first one is electrophilic substitution reaction and addition reaction. So due to the unsaturation in the benzene ring, we can expect electrophilic substitution reaction where electrophile can easily go and attach to the any one of the carbon atom and forms a substituted product. And not only it undergo electrophilic substitution reaction, our benzene can also undergo addition reaction also. First, I'll go with the electrophilic substitution reaction. Okay. So, we all know that electrophile in the sense it is nothing but an electron deficient species. Electron deficient species are known as electrophile, whereas nucleophile is an electron rich species. Electrophile means electron deficient species. Okay. The substitution of hydrogen atom of a benzene ring by electrophile is known as electrophilic substitution reaction. For that, I can write the benzene ring so that you will understand how this substitution reaction will be taking place in the benzene. Okay. This is my benzene ring having 3 alternative single bond and 3 alternative double bond and having one hydrogen. If you remove any one of the hydrogen and if you substitute it with any one of the electrophile, then the reaction is said to be electrophilic substitution reaction. Remember, if you remove any one of the hydrogen and if you react with the electrophile, then the reactions will become what? Electrophilic substitution reaction. Here I have mentioned out some of the electrophiles here, that is NO2, Br, Cr, SO2 and CH3. NO2 is a nitronium ion, Br is a bromium ion and Cr is a chromium ion and SO2 is a sulfur trioxide and methyl carbonate is a CH3+. So these are some of the example for the electrophile, which are electron deficient species, which goes and attacks to the benzene ring and forms a electrophilic substitution reaction. We'll take an example for electrophilic substitution reaction in the benzene by studying the nitration. So the name itself shows that it is a process of adding the nitro group to the benzene ring. Is it right? It is known as nitration. So the benzene on heating with nitrating mixture. So do you know what is nitrating mixture? It is a mixture of concentrated H2SO4 with HNO3. The mixture of concentrated H2SO4 with HNO3 is known as nitrating mixture. When you heat the benzene with the nitrating mixtures, which give rise to the nitrobenzene. This reaction, which is known as nitration. Why it is known as nitration? Because we have a benzene ring with one of the hydrogen. So it will be get substituted with the NO2 and forms a nitrobenzene in presence of nitrating mixture. In presence of what? Nitrating mixtures, it gives rise to the nitrobenzene. With the elimination of water molecule. How does the water molecule will be get removed out? Because one H from the benzene and OH from the nitrating mixtures will be get removed out in the form of water. So it gives rise to the nitrobenzene, where this nitro group will be get substituted to the benzene. We'll see with the mechanism so that we can easily understand how does this nitration will be taking place in a benzene ring. So the first step is formation of electrophile. It is very, very important. Okay. Formation of electrophile, that is NO2. How this electrophile will be formed? We know that we have a mixture of HNO3 as well as H2SO4. Is it it? H2SO4 and HNO3. You can remember OH from the HNO3 and H from the H2SO4 will be removed in the form of H3O plus ion, and you can see that there are two HSO4 ions will be there and it will be removed as 2 HSO4 minus, and you can see that one NO2 is remaining, and this will cause us a NO2 to become a electrophile. Once the electrophile which has been formed, so this electrophile can attach to the molecules of the benzene to give a carbocation. So this is my benzene ring, and which can easily get attached with the nucleophile, where one of the pi electron will be goes and attacks to form a carbocation. To form what? Carbocation. In the third step, carbocation can stabilize the resonance, and it is a resonance hybrid of following resonance form. So this is my resonance structure of the carbocation. We know that this bond again it will be moves up, and there will be a shifting of bond will be taking place. This resonance form, again the bond will be shifted here to form a bond with this, and finally we can write the resonance hybrid by writing the 3 bonds in the benzene ring, and you can see that there is a one hydrogen and one NO2 groups is attached to the benzene ring. We need to remove the one more hydrogen, so that the last step is carbocation can loses one of the proton and give rise to the nitrobenzene. So this is my carbocation reacts with one molecules of HSO4 and loses its one of the proton and get substituted only with the nitro group. Hence it is known as nitrobenzene. This process of obtaining the nitrobenzene from the nitrating mixtures, it is known as what? Nitration. So hope you understood with the reaction as well as with the mechanism. We'll go with the second example for the electrophilic substitution reaction by studying the halogenation of benzene. So the word itself shows that it is halogenation. Halogen in the sense the process of addition of halogen group to the benzene ring is known as halogenation. So the benzene, upon heating with the halogen in presence of ferric chloride as a catalyst and give rise to the halobenzene. So here I have considered my benzene ring, which is having one of the proton which is allowed to react with the halogen, and this reactions will be taking place in presence of anhydrous ferric chloride, and if you heat these reactions, the one of the proton will be get replaced with the halogen and forms a halobenzene. Remaining, the halogen react with the hydrogen and forms what? Hydrogen halide. So you can write one more example for this. I have considered the Cl as my halogen, that is a chloride. When you heat the benzene ring with the chloride in presence of ferric chloride, this chlorine will get substituted with the hydrogen and forms a chlorobenzene. Remaining one chlorine reacts with the HCl and forms H and forms a HCl. This is how the halogenations will be taking place in the benzene ring. Next is sulfonation. So here the benzene on heating with concentrated H2SO4, that is concentrated sulfuric acid, which gives rise to the benzene sulfonic acid, and this process which is known as sulfonation of benzene. So we have a benzene ring here which is allowed to react with H2SO4, H2SO4, or you can write this structure as OH SO3H. So H2SO4. Okay. So what will happen? The H and OH will be get removed out in the form of water. Remaining SO3H will become and attacks to this carbon atom and forms what? Benzene sulfonic acid. This process of obtaining the benzene sulfonic acid by using concentrated H2SO4, which is known as sulfonation. This is another example for a electrophile. Next is alkylation. So alkylation in the sense the process of adding the alkyl group to the benzene ring. So this is also known as Freedomcraft alkylation reaction. So the benzene on heating with monohaloalkane in presence of anhydrous aluminium chloride gives the alkyl benzene. This is also known as Freedomcraft alkylation. So here I have a benzene ring with the one hydrogen allowed to react with the halogen containing alkyl group in presence of anhydrous aluminium chloride. It forms what? Alkyl benzene. So you can write one more example for this. So I'll write benzene. So I'll consider CH3Cl as my alkyl halogen or halogen alkyl in presence of anhydrous aluminium chloride, and if you heat this reaction, so it will form toluene plus HCl. Toluene plus HCl. This is how the reactions will be taking place, where you can observe here the alkyl group will be get introduced to the benzene ring. Hence this process which is known as alkylation. So we'll see with the mechanism so that you will easily understand how does this alkylations will be taking place in the benzene ring. Okay. The first step is the formation of electrophile. So here the electrophile can be easily formed by the catalyst known as aluminium chloride combines with one molecules of haloalkanes to give electrophile. This is my catalyst. So in presence of haloalkane, so it will form what? This catalyst combines with the halogen and forms this intermediate complex where my alkyl group will become electrophile now. So what is the second step? This electrophile can easily attach to the benzene ring. So electrophile R plus attacks to the molecules of the benzene to give a carbocation. So you can see that this is my electrophile, which is nothing but a alkyl group which attacks to the benzene ring. So it forms what? carbocation. In the third step, there is a stabilization of carbocation by forming resonance structure. You can see that there is a movement of the pi electron to form a stable configuration. Again, this bond will be shifted here to form a stable electronic configuration. Again, this bond will be shifted here to form a resonance hybrid, where it consists of one alkyl group and one H plus ion. In the fourth step, we need to remove one of the proton so that our carbocation will loses one of the proton and forms a alkyl benzene. So this is our alkyl benzene, which having one alkyl group with one proton. So this is my intermediate compound which has been formed, where the catalyst is reacting with the halogen, and this halogen will accept one of the proton and forms what? Alkyl benzene, and this results in a formation of regeneration of the catalyst. This is how the benzene undergo alkylation to form a alkyl substituted product. You can see in the benzene ring. Hence this process which is known as alkylation. So the same reaction I have written by taking the haloalkane as this is my alkyl group and this is my halogen group. So what will happen if you treat the benzene ring with the CH3Cl in presence of anhydrous aluminium chloride? The CH3 group will be introduced here and H will combines with the Cl and forms what? HCl, and remaining CH3 will be get substituted and forms a toluene. For this reaction also you can write one more mechanism so that you will understand how the reactions will be taking place. In the first step, already we know that there is a formation of electrophile where our catalyst which reacts with haloalkanes to form an intermediate product with the electrophile formation. Here the electrophile is nothing but a CH3 plus ion. So in the second step, this CH3 plus ions will attach to the benzene ring and forms what? Carbocation. So the carbocation will be formed. In the third step, what will happen? There is a resonance hybrid stabilization will be taking place. So you can see that how this bond will be get shifted to form a resonance hybrid. Whereas in the fourth step, this carbocation which has to lose a one more proton with a catalyst so that it will loses a one more proton and forms a toluene. Forms what? Toluene, and this is how the entire product will be formed by the alkylation of benzene. Next is Freedomcraft oscillation. So the name itself shows that it is oscillation. Here, the acyl group will be goes and introduced to the benzene ring. What is that acyl group? RCO is a acyl group. RCO is a acyl group. So here I have considered the benzene which is allowed to react with acid chloride in presence of anhydrous aluminium hydroxide. It gave rise to the acyl group which goes and introduced to the benzene ring with the eliminations of HCl. So you can take one more example for that. So I have written the benzene ring where R is substituted with CH3, CO, Cl. Okay. So this is my acid chloride. So when a benzene reacts with acid chloride in presence of anhydrous aluminium chloride, the CH3CO will be get introduced to the benzene ring and forms acetophenol and with the eliminations of HCl. Okay. This is how the benzene can also form a acyl substituted benzene when it is undergo acylation. So for this also I have written the mechanism here. You can see that in the first step there will be a formation of electrophile. Here the electrophile is nothing but a CH3CO. How does this CH3CO will be formed? We know that this is my acid chloride react with the anhydrous aluminium chloride. We know that the Cl will combines with this and forms a AlCl4 and the CH3CO plus ions will be get generated. This is my electrophile. This electrophile in the next step reacts with the benzene ring and forms what? Carbocation. In the third step, it undergo resonance stabilization to form a resonance hybrid. It loses one of the proton by reacting with tetrachloroaluminium to form what? The acyl substituted benzene will be formed with the elimination of HCl as well as with the aluminium chloride. Again, this aluminium chloride react with the one more molecules of benzene ring in presence of acyl or acid chloride, and it undergo acylation. Like this, every time the catalyst will be get regenerated. This process, which is known as acylation of benzene or Vidhyaashram acylation of benzene. So there is a one more reaction known as combustion. So we will see what is combustion and how does this hydrocarbon will also undergo combustion. We'll understand now. When a benzene upon heated with the air, it burns with sooty flame and produces a carbon dioxide and water molecule. Already I have explained that when you put the new vessel on the any burning hydrocarbon, you would have seen that entire vessel will become very black because that hydrocarbon will be burnt with sooty flame. It produces a unburnt carbon in the form of soots. Is it right? So here also when you burn the benzene in presence of air, it produces a sooty flame and it gives to the formation of carbon dioxide with the water molecule. Here the benzene, which is heated in presence of oxygen, it gives to what? Carbon dioxide and water molecules will be obtained. Next we'll see with the addition reaction, where in presence of finely divided nickel as a catalyst, under the pressure, the benzene undergo hydrogenation to give cyclohexane. To give what? Cyclohexane. And this is one of the important addition reactions which is taking place in the benzene, where you can see that benzene is there, undergo addition reaction with in presence of nickel as a catalyst with the hydrogen, it get substituted with the one more hydrogen to form what? Cyclohexane. To form what? Cyclohexane. Similarly, the addition of halogen. If you add the hydrogen, it will become cyclohexane. If you add the halogen, it will become what? Benzene hexachloride will be formed. Let's see with the reaction now. Here I have considered the benzene, which is allowed to react with the chlorine in presence of sunlight. All three Cl minus Cl, that is the chloride ions, will be get substituted. So because 3 to the 6 chlorine atom will be substituted with the hydrogen and forms what? Benzene hexachloride. This is how the benzene undergo addition reaction by adding the hydrogen or by adding the halogen. Okay. So next topic is directive influence of functional group in monosubstituted benzene. So we'll see with what is the direct effect of or direct influence of functional group in monosubstituted benzene. When monosubstituted product is to be converted into disubstituted one, the existing substrate present in the ring, it directs the incoming group to the particular position. This is known as directive influence of the group. Depending upon their directive influence, various groups are get substituted or the functional groups can be divided into two categories. So which means to say that, suppose if I write benzene ring, okay, if it is attached to the para position, okay, so these two are the para, okay, these two are the meta and these two are the ortho. Ortho, this is also ortho, this is meta, this is para. This is also para position. Okay. Suppose if your substrate is there at ortho side, okay, or if your any electrophile goes and attacks to the ortho position, it will direct the other incoming groups to go and substitute at the meta or at the para position. So this is known as direct influence of functional group on the substituted benzene. This can also be understood by taking the two situations. So the first one is the substrate or the group which can direct the incoming groups to the ortho and the para position. It is very important. So the substrate group which is there in the benzene ring which direct the incoming group to come and occupy at the ortho and the para position. So for the example is CH3, C2H5, Cl, OH, Br, so on. So if we carry out the nitration of phenol, the mixture of ortho and the para nitrophenols are formed. This was explained by the following resonance structure. If you do the nitration of benzene, you know, especially nitration of phenol. So this is my benzene ring which are having the OH group. Okay, benzene with the OH which is known as phenol. We know that benzene ring which is having the OH group, especially oxygen which is having lone pair of electron which will be moved inside, so that there will be shifting of pi electron will be taking place, so that at this ortho position the carbon atom gains a negative charge. We know that that is not stable. Again it will be moves inside. This bond will be moves to the next position. Again like this the process will be continuous and shows that especially at the ortho as well as at the para, the substrate group, if it is already there in the benzene ring, it directs the incoming groups to goes and attacks only to the ortho and to the para position. That is why here I have considered the nitration of phenol. So you can understand that especially ortho and para substituted carbon atom is having the negative charge. This negatively charged carbon atom at the ortho and the para position can attract the electrophile from the outside and goes and occupies at ortho and the para. So this is the another speciality of the benzene ring. If it is already contained the substrate group, it directs the incoming groups to go and attacks on the ortho and the para position. So hope you are understood with this concept. We'll see with the next one, that is the substrate or the group which direct the incoming groups to the meta position. To what? Meta position. It is known as meta-directing group. Example, NO2, Cn, CHO, COH, COR and so on. Here I have taken out the example of nitration of benzene, that is nitrobenzene. This is my benzene ring which are having NO2 group. Is it right? So in this, we know that again the oxygen atom will having a lone pair of electron. Is it right? So this bond will be shifted here and again double bond will be moves inside, so that oxygen will get the negative charge. Since this carbon atom losing its bond, you know, it get the positive charge. Again this bond will be moves inside and this bond will be goes here and give rise to the positive charge at the para position. So this indicates that especially at the ortho as well as at the ortho, you can see that the ortho and the para as well as the meta groups which is there in the benzene ring which direct the incoming groups to go and attacks on the meta position or to the para position as well as to the ortho position. So this was a very interesting characters which is present in the benzene. If it is already substituted with any other electrophile which directs the other incoming electrophile to go and occupy at the meta, para and the ortho position. We'll move on to the last topic of this unit, that is carcinogenicity and toxicity. So benzene and many of the polynuclear compounds are toxic in nature and also they are known as carcinogenic agent because it causes the cancer, and polynuclear hydrocarbons are formed due to the incomplete combustion of organic materials like tobacco, coal, petroleum, and they can enter to the human body and undergo various biochemical reaction, and finally it can damages to the DNA. Once the DNA which is get damaged due to this biochemical reactions which is taking place in our health, you know, which causes the cancer. Example for the carcinogenic hydrocarbons are 1,2 benzene anthracene, 3-methyl chloroanthracene, 1,2 benzyl pyrene, 1,2,5,6 dibenzoanthracene. So this is the structure of carcinogenic aromatic hydrocarbon. You can see that there are 4 benzene group will be there. So it will be attached to the second carbon atom. So it is 1,2 benzene anthracene. So this is 3-methyl chloroanthracene. This is 1,2 benzene pyrene, and this is 9,10 dimethyl 1,2 benzene anthracene, and this is 1,2,5,6 dibenzyl anthracene. So all these compounds are too toxic. When we inhale such aromatic hydrocarbons, seriously it will damage the DNA and causes the cancer. So by this, I like to say that the hydrocarbons which I have covered in this session, it is very important for the examination point of view, especially the Vidhyaashram alkylation, Vidhyaashram acylation, and with the electrophilic substitution reaction. Have a look on it and try to work out. We'll meet you with the next unit. Till that, take care, be safe. Thank you.